Hey guys, what's up? Hope you're all doing well. So this is going to be the next stream in the Coding Minecraft, and I have not done any progress since last week. So I know I said at the end of the stream that I might try and solve the bugs that were present, but I haven't done anything. Good news is I do think I see exactly where the problem is. So if we take a look at what we had last time, basically just got to a point where we have a couple of weird triangles showing up, but they look completely wrong, and there's just two triangles and there should be a whole chunk showing up. Uh, and I think the problem is pretty clear right here. So let's see if we can figure this out real quick. Basically, what's happening is we have this element index, okay? And we have 6 faces of a cube, and we want to create the vertices. So we basically create vertex data here, and then we want to create the elements. So we try and create elements here, except I'm doing something really stupid right here. And I'm just using the same elements every single time. So these don't change, which means that we're not getting any new vertex data. So a little bit of a visual is probably going to help us. So I'm going to show my drawing real quickly. I finally did get my drawing tablet to work again with the stream setup, so we should be good. So basically you can see here that we've got this cube, and we've got all the different vertices labeled so that I know which ones I need to select. And what we want to do is we actually want to say, like, select 0, 1, 2, which will give us one triangle, then 0, 2, 3, which will give us the second triangle. And then what we want to happen next is actually say 0, 4, 5, which will give us this triangle, then 0, 5, 1. I think the easiest way to do this is going to be, like, if you look, for all of the sides, we have sort of the same pattern, and then for the top and the bottom, we have the same pattern. For the top and the bottom, it's literally just 0, 1, 2, 0, 2, 3, then it's 4, 5, 6, 4, 6, 7, which is the same thing every time, right? This is just 0 plus 1, 0 plus 2. That's 0 plus 2, 0 plus 3. This is 4 plus 1, 4 plus 2, 4 plus 2, 4 plus 3. So that's all similar. And then going down, these are always plus 4, right? So if we look at this, that's plus 4. That's also plus 4, and this last one is plus 4. I did not try and make it so that this would line up like this too. It just so happened that the way I laid out the vertices, this is all true. So using all this information, we should be able to, like, come up with something that should give us the correct solution pretty easily. So for the top face, we want to do this. Then for this face, we want to do 0, 4, 5. And then 0, 5, 1. Okay, and what I'm doing here is I'm trying to see if I can find a pattern, because if I can find a pattern, then I can roll this up in a loop inside of our code. So that's what we're trying to do. And then for this face, we're going to have 1, 5, 6, and then 1, 6, 2. And then for this face on the left side, we're going to have 2, 6, 7, and then we're going to have 2, 7, 3. And then for the last face on the back, we're going to have 3, 7, 4, and then we're going to have 3, 4, 0. Now, I can see a pattern here, and I think you guys should be able to see this too. Basically, if we look, this is just going 0, 1, 2, 3. Then this is going 0, 1, 2, 3. So that's the same. And if we look at this, this is going 4, 5, 6, 7, 5, 6, 7, 4. So almost the same thing. And then this one's going 5, 6, 7, 4, 1, 2, 3, 0. So we're basically wrapping at the 8th index, right? Here, let me just erase this real quick. So we're basically just incrementing, and then we're wrapping at the 8th index. This starts from 0, this starts from 4, this starts from 5. And then this one is kind of an oddball at the top because he doesn't follow any of the patterns, but he does follow the same pattern as this guy, which is 4, 5, 6, and then 4, 6, 7. Okay, and so these are the 6 faces of the cubes, right? We have 2 triangles per square, so that's what these are. And then we have 4 faces for the sides, and then 2 faces for the top. Or actually, I guess that's the bottom. So this is the bottom. This is the top. and these are the sides. Okay, so I think we can get away with this in 2 loops, right? We can basically say, okay, for this one, we just get 0, 1, 2, then we add 4 to all these. This is just 0 plus 4, 1 plus 4, 2 plus 4, plus 4, plus 4, plus 4. So that's easy. Top and bottom is good. And then for the sides, we can just go follow the 0, 4, 5, 0, 5, 1 pattern, and then just add 1 to all of them, right? And then we wrap at 8, which would be mod 8, right? And then that would change for each index, and we would basically add the offset. So then like for the next cube, it would be starting at 8, and it would be like 8 plus 4, which is 12, and then 8 plus 5, which is 13. So then it would be 8, 12, 13, and then we would wrap at like the next increment. Okay, so with that in mind, let's try and use this to our advantage and see if we can actually generate a cube, hopefully. So I'm gonna go back to the main screen, transition that real quickly. Oh, and how's it going, guys? Voxel Riffs, Emogi, and SC Woods. It's nice to see you all here. So basically, if you didn't catch it before, we've got a problem, which is, yeah, this doesn't look right. And I think I found out the problem. It's because I've got these, which aren't actually changing the elements. And so I was just sort of going over what I think should work to get the actual elements inserted correctly. So among that pattern, I'm going to sort of reference my drawing over here. What I'm going to do is we have the element index, and then we basically have 0, 1, 2, and then we also have this second one, which was here. I'm going to write this down over here. So this was 0, 1, 2, then 0, 2, 3, and then the bottom face was 4, 5, 6, and then 4, 6, 7. Which that's just plus. So we'll do that first because that's easy. So first of all, we need to get the correct offset, which for 0, it'll be 0, but then for the next cube, it will be 8. And then for the next cube, 16. So we're just multiplying by 8 there. So we should be able to say element offset equals 8 times, and then whatever specific cube we're on. So we can get that by our expansion here, which is this thing. So I'm going to take that expansion. I'm going to put it right here. So we'll just say this is the int array expansion. So we'll do that. And then this can change to array expansion. And I'm just going to make this const so that I don't change it on accident. Okay, cool. So then this is just going to be the array expansion, I think. Yeah, I think that should be good. I think it's going to be 8 times the array expansion. We'll try this out. We'll see what happens, and then we'll fix this as needed. So if we get the top and the bottom, we basically just have for I equals 0. I mean, I'm not even going to do that. I'm just going to sort of put the top and the bottom in manually. So the top is going to be elements, and then it's going to be element offset plus 0, which is going to be 0. Okay, and then if I duplicate this a few times, this is going to be plus 1, plus 2. This could be 1, 2, but we need to do the element offset plus that. That way we get an actual correct index, and I don't make the exact same mistake I just made a second ago. Okay, so we've got that. And then we've got this one, which is going to be 3, 4, 5. And then that's going to be element offset plus, and then we're going to be doing this pattern, which is 0, 2, 3. Cool. So that should give us the top face. And then if we want to get the bottom face, we can just copy this. And then we're going to say element offset plus equals 6. Should we do that? No, we should do plus equals 4. Yeah, and then it'll be the exact same thing. So then we can just literally use that same thing. Okay, so this should get us all the top faces and the bottom faces. I don't think we're going to get Anything else? Okay, we're going to get a read access violation or a write access violation. So this says element offset is this giant number. Thanks, Yo Mikester. It's good to see you too. For anyone who's wondering too, that's my brother. He's not a programmer, but he's coming in to say hi. So let's see. This element offset is out of bounds, and I have a feeling it's probably because of this thing. So trying to think. Okay, so we've got the elements, and we allocated how much? We allocated chunk width times chunk height times chunk length times 36. So we should get 36 elements per cube, which that all sounds right. And then down here, we're just saying the element offset is basically, oh, okay, it's this thing right here. That's wrong. That shouldn't be times 36. And yeah, oh wait, no, that's right. Okay, wait, no, that was right. That is right. I think it's this that's wrong. So we just change this. Okay, and then we can say element index plus equals 6. Yeah, that's, I forgot. So element index is different from element offset. We've got to keep those kind of separate. So let's see what happens when we do this. And if I run this again, hopefully we won't get... Okay, cool. So we didn't get an out of bounds error, but this still isn't working right. So that's something. Okay. So basically we're saying that this is equal to this. This is equal to the array expansion, which I said was equal to this. Actually, I think the array expansion should just be that. So I'm going to take out that times 8 and then add that times 8 back in here. Yeah, and then I think that should be right. Okay, let's see what happens now. Still the same thing. Cool. 2 triangles. This is making me think that maybe we have a problem over here, which is basically just taking x plus 0.5, y plus 0.5, and then I just sort of manually add in all these. Okay, I'm going to enter a breakpoint here, and we're going to go through this step by step. So if we're looking at this, what is this equal to? So we have x is 0, 0, 0. That makes sense. So then we get verts 0 is 0.5. Let's see. Yeah, I think it's just 0.5, 0.5, 0.5. I don't like the way that GLM actually sets all this stuff up here. I'm just going to do this because this is going to be easier. So we'll delete all that. And then I'm going to say verts 0 dot position dot x verts 0 dot position dot y and verts 0 dot position dot z. Okay, so that's 0.5. Then if we go forwards, it should change. Okay, so then we get z is 1.5, and then if we go forward, it should change. Okay, 2.5. So that's all looking correct. So this is actually changing. That's good. We should probably check the rest of these too. So if I change this to verts 1, we get 1.5, which does that make sense? We're adding 1 to x. Yeah, that makes sense. This is 0.5. That makes sense because, yeah, we're not changing anything there. Okay, yeah, so that's just going to be the same. So I want to say that the vertices are fine. Like, they shouldn't be the problem. It looks like they're all getting set properly. Let me see how I'm drawing this real quickly too. And I say this size is that, which that looks right too. Okay, so if I go back to the main window, or world.cpp, I guess. Oh, we're still saying GL draw arrays. And we're only saying 6. Okay, that would be a problem. So I should probably check what I'm actually doing here too. So what are we doing here? So we're saying create a VAO, create a VBO. That's all good. Buffer data, which is... Okay, yep. So that's the chunk we just created. So that's good. And did I just get a follow or something? Oh yeah, cool. Thanks. I'm not sure how to say your name, but I'm gonna say BlazXX. Thanks for following. Okay, so, and my brother is pretty cool as he would, so don't go check out his stream because you might want to stay there instead. And I have not made procedural generation yet, BlazeX. That's what I'm sort of working on right now. So we're just trying to get like a chunk generating, and then once I get the chunk generating, hopefully we can start with procedural stuff. So, okay, so we bind the EBO, and that should be all correct. And then we implement the vertex attributes. So this should just be position and then UVs. We upload a texture. Okay, so all this looks correct. It's just this line that is wrong. This should be GL draw elements. And I think this should say triangles, right? I think that's right. Here, I gotta get the IntelliSense working here. Okay, so enum mode is gonna be, yeah, triangle. Count is gonna be data dot element size bytes over uint32. Yeah, I think that sounds right. Okay. Type. Okay, I think type is going to be GL triangle. Or no, this is just going to be like uint32. I think something like that. We'll figure this out in just a second. GL float? No, GL uint. Yeah, okay, I'm going to look up the documentation in just a second because I'm not sure. And then this is just going to be data dot elements. No, this is going to be 0. Okay. Cool. Let's look up the documentation because I have no idea how any of this is supposed to actually work. So let's open up Google Chrome. And yes, it just renders the textures where player can see it, right? So not block per block. BlazeX, I'm not sure what you're saying there. Maybe just rephrase that. Basically, what I'm trying to do right now is just create one single chunk with a grass block texture. And then once I get that working, start on the procedural actual generating like different heights and stuff. So, but let's see GL draw elements. And let's look at the reference. Okay, so enum mode specifies what kind of primitive. Okay, so triangles is right there. Count is the number of elements to be rendered. So, so that's just basically how many elements we have in the array type. Unsigned byte, unsigned short, or unsigned int. That's the one I want. So change that to that. And then the last one is indices, specifies a pointer to the location where the indices are stored. That is 0 because of we already have that stuff stored in the vertex attribute array. So we should be good. Okay, so this says expected an expression. I don't know why it doesn't like this. Oh, because this should be size of uint32. Okay, there we go. Let's see what happens now. So if we run this again, gonna remove that breakpoint. Okay, now we get nothing. I don't know if that's better or if that's worse. But yeah, okay, so we get absolutely nothing showing up. Let's try and just draw the first 6. So if I go back to this, I'm going to say 6, or actually I'll do 36. So that would be 1 cube if that worked properly. And it might just be super big. No, I don't think so. I think it's just not working right. Okay. And you said BlazeX, so only the side the players can see renders to the texture even when breaking. Yeah, I want to get to, so you're talking about culling BlazeX, and I want to get to that eventually. First, we need to get it so that just all the sides are rendering, and then once I get that working, I can focus on like culling out the faces that aren't seen by the player and stuff. So, and I agree, voxel riffs. It never does work on the first try, but we're making progress, I think. So we're saying draw the first cube. And I'm pretty sure this is correct because we're not saying to use anything else. Are we? using the same VAO though. Are we binding the VAO? I don't think we are. Okay. GL bind vertex array. And then VAO. Okay. That could be something that was going wrong. Nope. Doesn't look like that was the problem. And if I look at this, did I actually do that anywhere up here? No. Okay. Yeah, I don't think it would have mattered anyways because we bind it up here. Yeah, right there. And we never unbind it. So that shouldn't matter. But it's there just in case. Okay, so we've got triangles, 36 triangles. Unsigned int, null pointer. Let's try and just manually use some vertices. Here, I'll do these vertices for now, and then we'll see if that works. Just to see if I'm using the element buffer correctly. So let's duplicate that and then comment that one out. And then we're going to say this is data.vertices. Size of that. Oh, wait. Okay. Oh, wait. No. That's. Change that to that. Okay. So we're going to change that to size of vertices, which are these. Okay. Yep. And then vertices. And then I'm going to comment this one out after I duplicate it. And this is going to be size of uint32. Or actually, I guess I'll say size of elements. And then elements. And we'll go ahead and we'll just create static uint32 elements. And then we'll initialize this to 0, 1, 2, 0, 2, 3. Okay. So if we have our elements drawing correctly, we should get a square when all this is said and done. Yep. So we buffer size of vertices. We buffer the vertices, size of elements, the elements. And then down here, I'm just going to say draw 6. Okay, let's see if this works. Okay, so our elements are not working. At least we get something now. But that's definitely not right. That is like very weird triangles. I think I know why that's wrong. Yeah, that's because I still have the color in here. If we remove the color and then run that one more time, do we get a normal square? Okay, so we get 1/2. This is better. We're closer. We get one side. Why is it not giving me the other side, though? This is, yeah, we should be getting a whole square because this is a whole square. This says top right, bottom right, top left. Oh, okay. I've got too many vertices in here. We just need top right, bottom right, top left. And then what's the last one? What am I missing here? Bottom left. That's what we need. Okay. So we should be good with just that. And then I just have to make sure these are ordered correctly. So this should be top right, bottom left, then top left. And then remove that comma. Okay. So those should all be ordered properly now. And we get a square. Awesome. Okay. It's always good when it actually works for some part. And thanks, BlazeX. It takes a while to understand a lot of OpenGL and stuff. It took me like 3 or 4 years till I finally understood a little bit of what's going on. But in answer to your question too, you can see I've got both sides of the face drawing right now. One thing we could do is enable GL's culling, which would only show one side of the face, which would be the front side. And then it would just hide the back side, which is something we'll enable a little bit later too. Okay, so that's good. That means that our triangles are generating properly. It's also kind of bad though, because it means there's nothing wrong with me drawing the elements. It means there's something wrong in the chunk generation. So that's going to be a little bit harder to figure out. But basically I can re-enable the chunks. And now I just have to make sure that all of this stuff is right. Okay, so let's check this systematically. So let's see if vertex size bytes is correct. We say chunk data vertex size of byte is size of vertex times chunk width times chunk height. times chunk length. So that's fine. And then we say times 8 because we have 8 vertices per cube. And that should be right. I mean, that's the exact same thing I'm using here. No, it's not. Yeah, okay, for vertex data. That's the same thing I'm using. Okay. So maybe I have something wrong with the data I'm using. So we say elements, we say vertices. Okay, no. So yeah, I get all the right stuff here. I'm just sort of allocating some memory here that I don't think I actually use. Okay. And BlazeX, this is not on Unity. This is just C++ and OpenGL. So no engine. That's the way Minecraft did it too. And I think it's probably best in Minecraft's case to not use an engine just because of how custom it is. So, okay. And it does look kind of like Unity's editor because I'm using Visual Studio, which is the same thing that Unity uses for C#. So, okay. We've got chunk width times chunk height times chunk length times 8. I'm saying the same things over and over again, but it's because I know that I'm probably missing something obvious here. So this seems correct. And then let's use a vertex instead, actually. So if I go back into world.cpp, I'm going to change this from float to vertex. And we're going to import that. Yeah, so we'll just do that. This way I can see if this part is actually working correctly. So if I did a vertex, then I could just wrap all of these in some brackets. And that should be correct if I specified vertex correctly. So just wrap that in a bracket. And that. And then we'll see what the problem is here. So it doesn't seem to like this. Let's see what we have for vertex. It's a GLM vec3 and then a GLM vec2. So I just also have to say wrap that. And let's actually just go down there, wrap that, and then wrap that. Okay. It's screwing me up because it keeps moving everything. Okay, let's see. We'll do that. And then we can wrap all of these. So I'm just going to do this. And then we're going to do that. Hopefully this all ends up working afterwards. Okay, that. And that. Okay, cool. So, yeah, I think that should be right. That should be fine. So these are just vertices now, which should theoretically be the same thing as it was before. Oh, what's up, kitty cat? Nice to see you here. And I like lion cat too. Okay. So these should all be vertices now, like actual vertex. So if I go back to the way we were doing it just a second ago, that should technically still work. Yep. So that should still be fine. If it's not, then we know that we have a problem with like the way we're uploading. Okay. Wait. Yep. So that's fine. Okay. So that means that the problem is definitely inside of our chunk generation, because there is absolutely nothing wrong with that. Yeah, okay, and I see absolutely nothing. So if the way I'm doing this, this would technically be the first triangle or the first square. So if I just draw the first 6 triangles, that should give me the same thing that we should be seeing, I believe. So if we go back to chunk.cpp, let's try and just make sure that this is working correctly. So we have this say plus 0.5 for all of these for the 0th position. And then for the first position, I'm sort of referencing my drawing here. We say that's plus 1 in the x direction. 0, 0. Okay, I'm already seeing something that is probably wrong. Okay, and then verts2 is verts 1 dot position minus 0, 0, 1 in the z direction. Okay, let's go back to my drawing screen just so I can see real quick. So I'm going to go back over here. Whoops. So we've basically got this, and I'm going to pick that color. I think the way I have it oriented is so that this is Y. That's a horrible Y. This is X, and this is Z direction, right? So this is positive X, positive Z, and positive Y. And so if that's 0, then that would be +1, and then 1 minus a Z, and then that would be 2 minus an X, and then 3 minus a Z. No, wait, that would be 3 plus a Z. Okay. So I just want you guys to sort of be familiar with what I'm referencing here again. If we go back to the code now and try and figure this out. So right here we say this is plus 0.5, 0.5, 0.5. So that should be like, according to my drawing, like the back right. So I guess technically this should be minus 0.5 if we want that to be the top right. Okay. And then verts 1 would be that 0 plus 1 in the X direction. Okay, that's right. And then verts 2 would be the 1 minus the Z direction. Okay, that's fine. And then verts 3 would be 0 minus the Z direction. That's right too. And then all of these are correct too because we're just kind of going down. Okay. That seems right to me. Let's see if that fixes anything, because technically if those were wrong, yeah, we would have had something wrong still. Okay, still not working. I'm going to go ahead and start logging some stuff too so that we can see what's happening. Okay. So if we go log info or logger info verts 1, and then I'll just sort of go through and do every single one just so that we can see. So we're going to do XYZ. And this is going to be position.x, vert0.position.y, vert0.position.z. Okay, cool. And then we're going to duplicate that, and that's actually 0. Okay, 0, 1, 2, and then 3, 4, 5, 6, 7. Okay, so this one should actually be part of this group. And that, and then I'll just do an extra line here just so that we can see what's going on. Okay, cool. So then we can change this to 1, this to 2. Yeah, and I know this is pretty laborious and stuff too, but that's how programming is sometimes, if you just want to be sure that you're getting all the correct values. And this is good so that we can actually fact check what we're doing. There's probably better ways to do this too than what I'm doing. So don't take my debugging methods as the best way. Okay, 6, 6. And then that's 7, 7, and 7. Okay, cool. And I'm going to put a breakpoint right there so that we can stop it. So if we run that and we take a look at our output, what do we get? Okay, we get 0 is minus 0.5, 0.5, 0.5. And I guess we should actually compare this to our main vertices that we were using over here, because this will sort of give us an idea of whether we're being close or not. So we get minus 0.5, 0.5. This says 0.5, 0.5 for the first one. So I already see a problem there, but technically we're not using the Z index here, and this is the top face, not a side face. So it's a little bit different. Okay, then we get 0.5, 0.5. Okay, I'm going to reference this against my drawing instead of that thing because I think that's probably going to be wrong. But let me check the chat real quickly. So you guys can't wait for the noise maps. Trust me, I can't wait for the noise maps too. Technically, we're not going to be using like a noise map. It's not going to be like me generating a PNG image or anything and then using that. It's just going to sort of be all happening in memory. So we're just going to be like using Perlin noise function to just sort of raise the terrain and stuff. And then hopefully layering several different Perlin noise functions to get more variety, which is what I think Minecraft does. Somebody sent me a cool article and stuff. So. Okay, Voxel Rift says it looks correct. I'm going to take your word for it, Voxel Rifts. But I'm going to double check this just one more time. Yep, okay, so minus, positive, positive. That's positive, positive, positive. Oh, and this is technically 2. Positive, positive, minus. Yeah, that's right. Minus, positive, minus. Wait, let me see that again. Minus, positive, minus. Okay, yeah, that's right too. And then that would all just be mirrored. Okay, so that should be fine. Yeah, that looks right to me too. I guess we should check the elements too. So let's see if those are correct. So let's just go ahead and say logger info elements, and then we'll just do %d, and we'll say elements 0. Okay, and we should have, we're gonna have more than 6 of them, but I'm just gonna do 6 for now. So 0, 1, 2, 3, 4, 5. Okay, so that should be 0, 1, 2, 0, 2, 3 is what we should get for those first 6. And I'm gonna have to actually scroll down to here, put a breakpoint. And I'm just gonna remove that one and step past that. Okay, cool. So 0, 1, 2, 0, 2, 3. That's perfect. Cool. Let's see about the last 6 then, if those are correct too. So this would be 6, 7, 8, 9, 10, 11. Right? Yep. Okay, yeah. So let's see if those are getting set correctly, because there's a chance that that's breaking. Okay, so we get 0, 1, 2, 0, 2, 3. Then we get 4, 5, 6. And then 4, 6, 7. Okay, that's all correct too. So something else has to be going wrong. Yeah, of course. It's all, I mean, it all looks fine. But something... So that tells me, though, that at least the first face of the cube should be showing. Because if all these values are correct, we should at least get that first face showing, and it should be fine. I wonder what this index is. So if we look at the array expansion, let's do this. Because technically, what is this verts? This is just like an extra array I'm making, like a temporary array. And then I'm putting it all into it here. So if this is wrong, then we have a problem. So if I go logger info verts index, and then I do %d, and we copy this. This should go 0 through 7 for the first face. So if that's wrong, then we definitely have a problem. We get 0, 1, 2, 3, 4, 5, 6, 7. Okay, so that's correct too. So the vertices, I'm pretty confident, are correct. There is one last thing though, which is this element index. So let's just log that real quickly. Elements index. And I guess technically I don't have to do these logs because I could just inspect the values, but it works. Okay. Oh crap. I forgot to okay, let's do Alt F4. Nope. Okay, we got to wait for this now. There we go. Okay, that's better. Cool. I forgot to put a breakpoint. There we go. Just want to see the first one, which is 0. So that's correct. And then after this, we get 0, 1, 2, 3, 4, 5. Should be 6 here. I don't see how it could go wrong, but let's just log it just in case. So if I do this, should be 6. Oh, and I forgot to put a breakpoint. Wait, there we go. Cool. Okay. Element index is 6. Okay, so everything looks fine. How many elements is this? This is 6, 12 elements. Okay, let's go back to world.cpp. We are using data.elements and data.vertices, and we're using the vertex size in bytes. This shouldn't be, this could be a problem. I wonder if that was breaking it. Okay, let's see. I'll change this to 12. Yeah, I have a feeling that was breaking it because we weren't uploading all of the elements. We were uploading like a tiny portion. Oh, okay, wait, I just saw something. Okay. Look at that. We got a top and a bottom face. Okay. So everything was correct. I just forgot, or I was using size of when I should have really not been using size of operator. That's funny. Cool. Let's see if we use 36, do we get... Whoops. If we use 36, we should get a whole cube. So if we run this again, we get the top and the bottom face, but we're not getting the sides. That's a problem. But hey, at least we're getting the top and the bottom face. That's good. Oh wait, we're not getting the sides. I know why, because I'm stupid. We only did the top and the bottom here. So we've got the top and the bottom, and then what do we want to do? We want to do the sides, which we saw there was a pattern, so I should be able to do this pretty easy. Basically, we can say for int I equals 0 until I is less than 4, I plus plus. I'm not sure if I should do these. Yeah, I'm going to do it like this for now. Once we get to like custom blocks, like fence blocks and all that type of stuff, it's going to be a little bit weird because they're not a square. They're not just squares, right? So we're going to have to come up with a whole different technique for loading structures. Yeah, so we'll have to take a look when we get to that. But for now, this should be fairly simple, right? We should be able to just say the pattern here is 0, 4, 5, 0, 5, 1. And then we just add 1 to each of those, and we wrap every 8th element. Okay, so the element offset wraps every 8th element, so we just need to do modulus 8 plus... Yeah, okay, that makes sense. So we basically just need to do element offset plus 0, this thing, plus 0 mod 8. That's sort of going to be the style we're going to be using. Am I skilled on the keyboard behind? Oh yeah, Essie Woods, I'm sorry. I noticed you asked that at the end of the last video, and I just kind of closed the stream because I didn't see that. But I do use the keyboard in the background. I don't use it to make my YouTube music. I just use the YouTube audio library because I'm not good at making music. I just like to play other people's music. So I think me and the Real Kane on the Discord server were talking this a while back too. And I typically like to play like music from movies and stuff, especially Pixar. Like Pixar has a ton of great music. But different movies too. Hans Zimmer is a great artist. You should look up some of his music if you don't know. But he like directed the orchestra type stuff for Dark Knight and those types of movies. So very good. But yep. And you're trying to make a song from binary codes. That does not sound fun. But it does sound fun though. I don't know. I think I would enjoy that. But okay. Anyways, element offset plus 0 plus mod 8. So we basically want to do this, and we're going to be going 0, 4, 5, 0, 5, 1. So we'll do that. 0, 4, 5, 0, 5, 1. And then we need to increment all of these plus 1 every time. So basically we can just do this plus I, plus I. Okay, yeah, and that should be good. Do the same thing here. And this is a very strange way to write code. I don't usually write my code like this, but it makes sense since we're kind of doing math stuff here. Okay, so that should give us the correct stuff. And then we basically just want to get the correct elements index. So if I copy all that, actually that's not going to work. If I copy that and we paste it there, that's good. Let's see if I can, oh cool, I can do that. Okay, cool. So we'll just paste all that. This could be element index plus, so what do? We'll do element index plus equals 6 here. So that way we should be at the correct offset. And then every time we do one of these, we can just say element index plus equals 6. And this will be 0, 1, 2, 3, 4, 5. Okay, let's see if we get a cube now. With luck. Fingers crossed. Whoa. That's not a cube. That is really cool though. I'm not sure what I just did there. I like it. I don't know. I think it's cool, but it's definitely not a cube. Let's see what I did wrong. Okay, so this is plus equals 6. That's right. Did I make the side of the bottom? I have no idea what I did there. It was just really weird. Okay, so we've got element and index that increases every time. Element offset, which according to my calculations would be 0, 4, 5. Oh, this is mod 8. Okay, yeah, that's fine. That's fine. Right, so if we did 0 plus I and I was 0, that would be 0. Mod 8 is 0. 0 plus 1 would be 1. Mod 8 is 1. And just for reference too, so you guys can see what I'm looking at, let's go back here. I am looking at this little map that I made, which, oh man, didn't mean to do that. This thing should give us the side. So if that's correct, then we should be getting the correct information. Okay, let's go back to this. So if we did 5 plus, let's say 3, which would be my last thing in there. 5 plus 3 is 8. Mod 8 is 0. Oh, okay, I see what's wrong. We should be getting 4 there. So we're going 5, 6, 7, then 4. Which is kind of weird. 1, 2, 3, then 0. 4, 5, 6, 7. 1, 2, 3, 4. Wait, maybe I had that wrong. 5, 6, 7. Here, let's go back. I'm going to show you guys my drawing. Yeah, I can't believe it's July either. Time goes by quickly, especially as you get older. I'm not even that old, but it's definitely different from when I was like in high school or in middle school. Okay, so is this right? This says 0, 4, 5, which would be that. 0, 5, 1, which would be that. That's correct. 1, 5, 6, which would be that. That's fine. 1, 6, 2, that's fine. 2, 6, 7 is that. That's fine. 2, 7, 3. Yep, that's right too. 3, 7, 4, which is that. 3, 4, 0. 3, 4, 0. Am I doing this wrong? I think this might be 3. Let's see. Because this last number just doesn't make sense. I think I'm doing something wrong here. Because this goes 4, 5, 6, 7, 0, 1, 2, 3, and then 5, 6, 7, 4. So that doesn't seem to work. Okay, so 3, 7, 0. Okay, so that should be a 0 is what I think is wrong there. Let me just correct this real quickly. Whoops. My setup is kind of messed up back here. Okay, so that should be a 0. So we go 3, 7, 0. And then it would be... No, that doesn't look right though. So if we go 3, 7, 0, that's what we get. Whoops. But then this would be messed up because 3, 4, 0 would give us that. We'd have to go like 3, 7, 0 and then 7, 4 or 0, 7, 4 or something like that. Which doesn't make sense here. Okay, so maybe the way I set up my vertices isn't completely correct. No, I'm not going to play Hans Zimmer to the outro. I wish I could because I love his music, but probably get copyrighted. Okay, so let's see. This last face is just kind of weird. So 0, 1, 2, 3, 4, 5, 6, 7. Okay, so that's all fine. I think I'm probably doing this part wrong. If we just follow the pattern, though, this would be 0, 1, 2, 3, 5, 6, 7. This would be 0. Let's just erase this real quickly. 0, and then 1, 2, 3, 4. So 3, 0, 4. 3, 7, 0, 3, 0, 4. Yeah, that's still not right. Is this right too? 0, 1, 2, 3, 4, 5, 6, 7. 5, 6, 7, 0. Yeah, because all of these ones are right. But that still doesn't make sense why we would get the wrong thing in our view, because it would just be the back face that's messed up. This is when things get a little bit tricky. I could avoid all of this too by just doing this last part manually, which I might just do. So we could go 0 through 3. And then for the last face, it's just 3, 7, 0. Or no, we would do 3, 7, 4. I think that's what it should be. 3, 7, 4, 3, 0, 4. Yeah, which is what we had before. So if that was a 4, then we would get this. And then we would get that. Yeah, that sounds right. Okay. I'm just going to do this last face manually because I think that's going to work a little bit better. So, I like the chat emojis. Okay, so we'll just go up to 3 here because the last face stinks. So, last face stinks, and then we'll just do that one manually. So this should be 0 plus. Okay, so then we can just get rid of all of that. We can get rid of all of that. And then this would be 3, 7, 4. And then this would be 3, 0, 4. Okay, cool. So let's see what happens now. I don't think it's going to be right still, but we can hope. Okay, yeah, so we still get the weird thing. I really like that, though. I don't know. It's cool. It's just not right. Let's log what is happening here. Let's see what's going on. So we'll say logger info and just make sure that this is matching what I think it should. Elements. I'll do %d is that. And then we'll say element index plus. Oh, crap. 0. Okay, that'll be fine. And then this should be elements element index plus 0. Okay. We'll do that. Space that. And then actually I'm just going to do new line here and then a new line here. A double new line just so that we can see that pretty easily. Okay, so then this will be 0, 1, 2. 0, 1, 2. 3, 4, 5. And 3, 4, 5. Okay, let's see what we get. Hopefully it looks correctly. Oh, and yeah, I forgot to stop that. Now we gotta wait. Hopefully not too long. This kind of reminds me though. I don't know if you guys watch Casey Muratori that much, but I love him and I think he's awesome. Yeah, ... is good, but story time now. But Casey Muratori just recently released a little video, and it was called like console rendering is slow, or why is console rendering so slow? And I thought it was really interesting. What country am I from? I'm from the US too, by the way, or Voxel Riffs. I don't know if you're asking him. But anyways, Casey Muratori had this and everything, and he basically wrote his own console just to prove that like it shouldn't be as slow as it is in Windows. And he was getting like 7,000 frames per second, which was insane. And he was like, yeah, you can change the font, you can change the font size, you can use, and then he showed you can even use like Arabic glyphs and everything, and it was working fine. So really interesting. And he said he wrote it up in like 2 days because he basically opened a ticket to Microsoft and was like, hey, why is your console so freaking slow? And they were like, oh, it's like a PhD level project and everything. And he's like, I just wrote this up in 2 days. And he's like, and it's way faster than your console. So yeah, but it was pretty cool. Change the texture for the top, for the top and bottom and side. We'll get around to that. But anyways, let's go ahead and we're going to put a breakpoint right here just so that we get all this. You guys should watch the Casey Muratori video though, because it's very enlightening and I love all his stuff. He's just a pretty funny guy. Okay. Oh, this is like, does not look right at all. So that's good. At least we know it's wrong. We should be getting like 045 for these first ones, and we're getting 489. Yeah, that's not correct at all. So I think the problem here is this element offset, which should be correct. Like that should be 0. So then we should be getting 0 there. So if that's 0, that should be doing nothing. Let's, here. Element offset. And we do that. Got the breakpoint. We're good. Yeah, that's true. It's good when you find stuff that's not right, because then it helps streamline the debugging process. Okay, yeah, so it says element offset is 4. So that is a problem. I think it's because, yep, it's because of this thing here. Okay. Is this a problem? Yes, this is a problem. We can just do element offset. Actually, we'll just do the bottom face after we finish. No, yeah, I'm going to leave this the same. We'll just do that. And hopefully it works. I'm going to log this just to make sure it's still right. So we should get 045, that is correct. 051, that is correct. Then we should get 156, that is correct. 162, that is correct. Then 267, 273, awesome. Cool. So let's comment all that stuff out. Remove the breakpoint, let's see what happens now. Hey, we got a cube, I think. Wow, that's very strange. I think we have overlap. I think that's what's happening because, yeah, it just looks very weird. Okay, yeah, so we're still getting the top and the bottom, and then we're getting all the sides, and it looks like we have Z fighting going on, which is when you have two vertices that are on the same index. That's what that looks like, at least. So I must be duplicating something somewhere. And that's why we're getting this weirdness. Let's see. So this all seemed correct. So I'm going to remove this because I think that's right now. And rendering a cube, encountering all the problems. Yeah. Well, technically we're rendering a cube, but once we get this cube working, we should get a whole chunk. So it's a little bit more complicated, hopefully. Maybe I'm just making this way more complex than it needs to be. Let's remove the last face because that was the one that stinks. Maybe he's messing everything up. So if we run this again, we get... No, we still get some weird stuff. I have a feeling this is probably because of the UVs. I think I set those up wrong. Oh, wait, actually, I don't think I'm even setting up the UVs. Am I? Am I? Let's see. Okay. So we get this. We say set the UVs. Oh, okay. I think I know what's going on. Let's switch back to drawing screen because this is important. So go back here. Okay, so what's happening, and is there a good way to solve this? Probably not. I mean, there might be, but I don't know. We'll have to see. So basically, what's happening is I'm setting this UV coordinate right here to 1, 1. we're setting this one to 1, 0. And then we're setting this one to 0, 0. And this one to 0, 1. And you may be thinking, that sounds fine. It is fine. But the problem happens when we go to set this one. So this one is also 1, 1. This one is also 1, 0. This one is also 0, 0. And this one is also 0, 1. So what we end up with is basically just 1 pixel. Not even. We have 0 pixels for this entire face. I think that's why it looks so strange, is because it's trying to stretch 0 pixels across the entire face, which it can't do. So how do we fix this? The easiest way to fix it is just to duplicate the vertices. I don't like that because then we're duplicating vertices, but I don't think there is any good way around this. Does anyone know of like any 3D techniques they do for duplication of vertices for like UV coordinates? Or maybe that doesn't exist. Let's Google stuff real quick. So we'll do that. I'll transition my screen back to this. Okay, so 3D duplicate vertices for UV chords. Let's see. Why do 3D models have duplicate vertex positions with different UV chords? I'm experimenting with exporting the Collada format from Blender. Shouldn't it have 1 vertex and 1 UV? Okay, a vertex is defined by a combination of all information. So if your vertices are 5-dimensional, X, Y, Z, U, V for any 2 vertices, if U1 is not U. Okay, yep. So GPUs, so it's still not standard to add that level in direction with programmable GPUs because it's spending more memory, but people generally don't. A vertex shader has no concept of where the vertex is processing, ordering, so as long as the geometry pipeline keeps track of the problems ensue. Okay, so he's basically saying that Blender exports duplicate vertices for different UV coordinates. That makes sense to me, but do people usually eliminate that duplication somehow? I'm just reading this. Okay. So this leads me to believe that the whole element indice thing that I set up is just completely useless, and I think it might be. So that removes a lot of complexity, which is nice, but it also means that we have to remove a lot of code. Let's see what this says. Okay, how can I UV map an object without duplicating edge vertices? Any non-flat shape object with a decent UV mapping will have split vertices. You can UV map anything without splitting any verts, but there'll be super stretched and warped parts. If you look at how to unwrap, it's all about trying to hide the seams and whether you can get away with only slightly warped. Okay, so basically we're going to have to duplicate vertices, which is fine because we're using very low poly objects. So that also means that the whole element thing that we were doing here is kind of useless. We're going to have to rethink this. Okay, back to drawing screen. So let's go back here. I mean, good news is we got it working. It's just that you can't really use this method. So I'm going to have to remove, actually, let's keep that because that's important. X, and then let's remove all of this stuff because that is no longer important. It's still kind of important to remember how these things are working. We still might need an element index just so that we don't duplicate like these vertices for each square. But then it's just gonna be 0, 1, 2, 0, 2, 3 for all of these. That might not make any sense, but yeah, this is starting to look like school. Yeah. Okay. So thinking about this critically, I think the easiest way to do this is just going to be to do all 6 faces manually. Let's do that. So we're going to write a lot of code. I don't really care. And it's going to be way less complex, so that should be good. Okay. So we have all this commented out because I don't really care about that anymore. And we've got all the vertices, but we're actually going to need more vertices. So we need 4 vertices per face, and we're going to need to duplicate those for each face. We have 6 faces on a cube. That's 24 vertices per cube. Right now, we're going to change this, of course, in the future. But anyways, 24. So instead of allocating just 8, we're going to be doing 24. Elements should be the same. Yep, I think so. Yeah, so we should be good there. Good news is we can probably... Okay, no. Okay, so we basically just have all of these, and then we want to figure out a way to get them all into the correct data positions. Okay. Get take some water real quick. So, this gives us all... This is probably just completely useless now. I'm going to comment that out because that's not even going to help us anymore. But this is still going to help us. So basically, instead of just going through 8 vertices per cube, we're going to need 24. Okay, so we need 24 vertices per cube. And how is this going to work? We're basically going to say... I really just don't want to write it all out, but I think writing it all out is going to be the simplest thing. And then if we see some patterns, we can abstract away. So let's just go and write it all out. So vertex data, array expansion plus 0 equals verts 0. So we're going to comment this out too. And we're going to write 24 lines of code. It's not that bad. So 4. That should be our first face, and then we'll do that. Second face, so on and so forth, and we have 6 faces. Yeah, this isn't that bad. Okay. So 3, 4, 5, 6. Okay, so that's 6 faces. That's all fine. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I'm going to change all these to 1s. 17, 18, 19. Okay, did I do some math wrong? Because we only have 20 here. We have 6 faces. 1, 2, 3, 4, 5. That's 5 faces. Okay, that's what I did wrong. Face 1. This is top face. We'll do, this is right face. This is going to be forward face. This is going to be left face. And this one is going to be back face. And this one's going to be bottom face. Okay, cool. So I did have the right number. I just didn't finish filling it out. So that's 21 or 20. And then that's 21, 22, 23. Okay, cool. 24 vertices. And we just fill it in manually, which shouldn't be too bad. So this one is going to be verts 0. This one's going to be verts 1, 2, 3. And then we also need to fill out the elements and everything. So I'm going to say elements array expansion plus 0 equals 0. We basically need 6 of these per cube. But we might, I think this is going to be very similar. Like we shouldn't, as long as we order all the vertices the correct way, we should be able to just say, like for int I equals 0 till I is less than 6, I plus plus, elements, element index plus I equals element offset plus 0. Yeah, okay, we should be able to do something like this for the elements. So I'm not going to worry about those. I'm going to remove this because we're basically going to just sort of scratch all of this stuff. Okay. This is good, though. I guess this is a good lesson in, like, complexity, right? Sometimes the least complex answer is the best, because with the last one, it was really hard to figure out what was going on, and I was having a lot of problems that we couldn't figure out. But with this, it's going to be very straightforward exactly what's happening, and I know what all the values should be exactly. So yeah, I'm okay with this. Okay, but we do need to do this stuff. Technically, this should be dot position equals all that stuff. So what am I doing wrong here? Because that should be, yeah, this is vertex. Vertex data. Yep, that's right. So we should be able to say dot position. Yep. Equals, what's this saying? Oh. Oh, okay. I see what's going on. So this should be dot position also. There we go. That's better. So now we're all happy. Change this to position. I'm just going to copy that. Paste. Just copy that. Paste that. Oh, crap. I built it. Okay, there we go. When you accidentally hit the wrong keyboard combos, it can be bad, because if you trigger a build in C++, that can take quite a while. Okay, so we do that. We do that. And that. And finally, that. Okay, cool. So, over-engineering is bad. Something I need to get into my head. Yeah, I agree completely, Voxel Riffs. A lot of my solutions, I'm like, okay, I have to stop and just code the simplest thing. That's part of the reason why my latest game engine devlog has been taking so long, is because I've been over-engineering the crap out of my game engine, and I'm finally like, okay, I got to stop doing this and just focus and like code the basic stuff. So hopefully that should be coming out within a couple weeks, but I keep saying that, so we'll see. Anyways, though, we've got all this. Then I'm going to copy that, and we're going to set up all of the UVs. So this is going to be UVs. UV equals, for now, we'll just say vec2. Actually, we could just say that. Okay, so this one is 1, 1. This one is going to be, got to think about this. Let's go back to here and see what I did up here. Okay, so I said top right should be 1, 0. Yeah, I don't think it matters too much for the top and bottom faces. Okay, so this will be just 1, 0. Whoops. 0, 1, 0, 0. I'm not doing anything fancy here. I'm literally just putting these in, and then we'll see if it looks okay. It's probably not going to look okay, so, you know, we'll fix it. Okay, so this is going to be 4, 5, 6, 7. For this one, I am going to focus. So this is top right. 5. Oh, crap. Okay, I got to fix this too real quickly. So this is just 0, 1, 2, 3. That makes sense. For the right face, this is going to be 0, 4, 5, and what is that? Oh, that's a 1. Okay. Having trouble reading my handwriting. Okay, 0, 4, 5, 1. So then that's top right. That's bottom right. So we want to do, yep, 1, 0. Bottom left, which should be 0, 0. And then that should be 0, 1. Okay. So copy that. And then the forward face is going to be vertice 1, then 5, then 6, then 2. Okay. And then for this one, we're going to be, that's the top right, bottom right. Yeah, I'm trying to order these. It's going to be the same every time, which should be good. Top right, bottom left, top left. Cool. That's good. And I also need to change this to 8, 9, 10, 11. Okay. The left face, let's copy this. Almost done, guys. We're getting there. Okay, so the left face should be, let's see, 2, 6, 7, 3. 6, 7, 3. Okay, and then that should all be fine because we're using the same layout every time. This could be 14, 15. I'm actually going to change the very first one too, just to match this. So this should be 0, 0, then 0, 1, which I think is, yeah, 0, 0, 0, 1. Okay, cool. We could probably set this up because this is all repeating. Yeah, so we could loop this because this is all repeating, right? Let's do that. So we'll say for int I equals 0 until I is less than 6, I plus plus. And then we got to get, so we have the array expansion, so that's good. Array, whoops. We'll say array expansion, or actually vertex data. Array expansion plus I dot UV equals 1, 1. And then we can just copy that. Plus I plus 1 plus I plus 2. And then one more plus I plus 3, which is 1, 0, 0, 0, or 0, yeah, 0, 0. And then 0, 1. See, this is what I'm saying too. When you start writing things out manually, you can start to see the patterns and then just abstract those away. So we should be able to just do that. We also have to do plus I times 6, which should get us, or actually times 4. Okay, there we go. Cool, so times 4, that should all be good. So now I shouldn't have to worry about the UVs, just getting all the vertex positions correct. Okay, so we did the left face and then the back face. What is that going to be? That's going to be 0, 3, 7. And then that is 4. Okay. And then the bottom face, what is that going to be? That's just going to be 4, 5, 6, 7. Okay, cool. So we've got the positions, we've got the UVs. Now we just have to do the elements again, which is just going to be 0, 1, 2, 0, 2, 3 for every single one, except we need to make sure to increase that. So we'll say int element offset equals array expansion times 36. Yeah, I think that's right. And then basically here we'll just say plus I element offset plus I plus 0, 1, 2. We need 3 more. That should be 3, 4, 5. And this should be plus I times 6 plus I times 6. Cool. So that way we get like the correct index. Okay. And then this is going to be, oh crap, this should be element index, which equals array expansion times 36. Okay, so that should be fine. And then element offset is going to be array expansion times 8. Nope, times 6. Okay. We'll find out in a minute if this is all good too. So then we get a 0, 1, 2, 0, 2, 3. That pattern should be good. And then we're going to say element offset plus equals 4, which should get us to the next round. Okay, let's see what happens. Fingers crossed, we should get a cube this time. Holy crap, I almost got it first try. That is the best thing we've gotten all this time, I think. Okay, so first of all, I've got my Z index upside down, or my Y index upside down, I guess. And then I've got forward face looks wrong because we've got forward face on the wrong side, and then the bottom face is on the wrong side too. Okay, so let's take a look at those. That could potentially just be the elements. Thanks for coming, BlazeX. Yeah, we are so close. Okay, so let's see. So we've got element offset. This is correct, I think, because we don't have any problems with our triangles. So I'm not going to worry too much about that. The UVs are correct too, because all of the textures looked fine. So the only problem we have is the vertex positions. Let's see if this is correct. I think this is all correct. I think we're fine here. Actually, no, this would have something wrong with it, wouldn't it? Because if we look at this again, yeah, the only way we can be getting stuff over here is if we have a couple of vertices that are the wrong thing. Is it just the way that we're looking at the world? Does OpenGL have like the Y direction as pointing up and down? Or do we have to define that somewhere in like the way we're rendering? I think our camera. So our camera should define that, which we do. We say 0, 1, 0 is the up vector. Yeah. So then if we go back to our world.cpp, let's see. Actually, we can just use this to kind of experiment and see which directions are which. So I'm going to recomment these. Okay, so let's see which direction this face is facing. Okay, so this is going up and down. And yeah, so this is going up and down. So the top, which is what we would expect because Y is the vertical in this case. And then X is forward and backward. Okay, so that's all correct. Just wanted to make sure that our coordinate system was correct. Okay. Then we've got this, which I think is correct based on our drawing. So 0 is minus X, positive Y, positive Z. And then 1 is 0 plus 1 in the X direction. That's fine. 2 is 1 minus 1 in the Z direction. That's fine. 3 is 0 minus 1 in the Z direction. That's fine. And then 4, 5, 6, 7 are just all of those minus 1 in the Y direction. Yep, that's all fine. Okay, so maybe it is this element index then that's wrong. What's up, The Real Kane? Glad you could make it. We are just debugging right now, which I think is going to be the majority of these streams. Hopefully not. Okay, so I have a feeling something's going wrong here. We've got I times 6 plus 0. 1, 2, 3, 4, 5. Let's take a look at the drawing again. Or not the drawing, but the render. Wait, well, okay. I forgot to switch the rendering. Let's change this back to that one. We'll change this one back to that one. Okay. I mean, good news is, though, that the chunk is generating super fast. So once we actually get chunk rendering working, that should be good. Something weird is going on up here, I think. Yeah, we've got like a little mini square. Do you see that? I don't know. Okay. Well, no, that top face looks fine. That side looks fine. That side looks fine. That side does not look fine. Something very weird is going on there. Oh, you know what's going on? I don't think we have Z-index working. That's an OpenGL thing. GL Z buffer. Yeah. Depth testing. Okay, we need to turn this on. That's going to help a lot. So let's enable that. And we need to clear the color bit and the depth buffer bit. Okay, cool. See, I work in 2D so much, I completely forgot about this stuff. So this needs to be the depth buffer bit. Okay. Let's run this again. Maybe that was why it was looking so strange. Okay, yeah, so that was definitely why it was looking weird, but now we can clearly see what's going wrong. So it's definitely the forward face and the bottom face that are wrong. But at least it looks normal now. That's cool. Yeah, I did not enable depth test. I just saw that voxel riffs. Thanks. Okay. So let's go back here. I need to check the chat more often because you guys often tell me what's wrong before I realize it myself. So forward face and bottom face looked wrong. So forward face, I said that's 1562. Is that right? 1562. That's right according to my drawing. Maybe it's the back face that's wrong. So I said that was 0374. Instead of that, let's try 3740. Okay, let's see if that fixes things. Maybe, maybe not. Nope, that did nothing. Yeah, it's really weird because I know I have all the vertices right because we have this thing right here, which shows that we have all 8 vertices in the correct positions. It's just these 2 faces are completely wrong. Let's try the bottom face because I think that'll be a little bit easier to figure out. So 4, 5, 6, 7. Yeah, that's right for sure. If I were to change this to 0, 1, 2, 3, we should see one of those faces disappear, which should tell us which one is technically the bottom face. None of those faces disappeared. This is strange. I don't know what's happening. Huh. Yeah, this is really weird. Wait, maybe I know what's happening. So we have, let's see, 6 elements per face. Yeah, 6 elements per face. We have 4 faces. Or no, we have 6 faces. Yeah, that's 36 elements per cube. Yeah, so that's definitely right. And then if we go back to world.cpp, we're just drawing the first 36. If I were to draw the first 24, that should give us the first 4 faces. Or no, like, I don't know how many faces. Okay, yeah, 4 faces. Cool. So we only get 4 faces there. That makes sense. So then if I were to literally just comment this stuff out, these 2 things, then it should do nothing. It should change nothing compared to what we see. Okay, and it doesn't. It changes nothing. Okay, so that's all good. So our assumptions are correct. It's just these 2 things that are broken. So I need to fix those 2 faces, and we need to see what fixes them. If I change this back to 36, we'll see the broken part again. Okay, yep, so we see the broken part again, but we definitely know which faces it is. It's these 2 faces. So this says 3740, which is somehow completely wrong. Let's see, I'm going from top right. So 0374. Let's try that. Okay, let's see if this changes anything. Maybe, maybe not. Nope, still doesn't change anything. Okay. Wait, maybe they're getting overwritten. I think that might be what's happening. It's getting overwritten by the next face. Yep, that's definitely got to be what's happening. So we say verts 8, and then what do we say? Array expansion. And what is array expansion? It's x plus chunk width plus times that. Which is almost right, but it's not right because we have 24 of these per face. So if we technically wanted that to be right, it would be 24. Was that what it was before? That's funny if I made the same mistake again. Okay, so this is vertex offset. Okay, let's call it that, which is array expansion times 24. Okay, and then this should stop it from overwriting everything. So if we just go through here and then we just say find in the selection array expansion, and we're going to replace it with that replace. Cool. Okay, now if we run this, do we get a cube? Holy crap, we got a cube, guys. Almost. Oh my gosh, almost. I messed up the bottom face because I changed this, right? Okay, yeah. So if we just change this back to 4, 5, 6, 7. Okay. We finally have a cube. This is working now. So our UVs are a little bit messed up. It's like rotating every time. Well, actually, these two sides are good. Those three sides are good. And then that side is wrong. So I think that's probably the back face. That was the one that I kept messing with. Holy crap, I can't believe it's actually working. Okay, let's change this back to 3740. I think that's the proper orientation, which means that we would get all of our UVs in the same direction. So bottom, that's facing the bottom, that's facing the bottom. Okay, cool. So now they're all facing to the bottom, so they're all the same direction. I just have to change the orientation. And that's facing this way, and that's also facing this way. Okay, cool. So our UVs are correct and everything too. We just have to swap top and bottom. So this should be 0, 1, 1, 0. And if we do this, it should be facing the right way. It's facing the right way now. Okay, finally. Cool. We just don't have the grass top and the grass bottom, or I guess dirt. That's something we'll have to figure out a little bit later. Okay, but for now, let's go back into world, and we should get a whole chunk if we just change this to data dot element size bytes over size of uint32. Let's see what happens now. Yeah, finally a cube. But see, like I said, the good thing is once we get a cube, oh no, we should be getting a chunk, but that's not a chunk. That's just sort of 1/16 of a chunk. It's so close. What's happening up here too? This is really weird. It's just all green. Yeah, it starts getting very strange up there. Huh. Oh, and then I got a weird Windows sound. It didn't like something. Okay, so I think that's fine. What's this saying? Oh, we've got like a little squiggly. Implicit conversion loses integer precision. Okay, that's fine. Let's go to our thing right here. We'll say uint32 number elements. And then we'll just set that too. This should make it a little bit easier. Which is going to be all of that times 36. So we'll say ret.numberElements equals that times 36. And if we go back to world.cpp, we can change this to number of elements. Okay, I think that should fix anything if we might have had some problems with like the element. Okay, yeah, cool. Wait, no, dang it. I just got duped again. Okay. So we're still having problems. Like it gets to a certain point and then it just starts screwing up inside of our chunk generator. So we're saying go chunk width, chunk height, chunk length, which should be fine. All of those are generating, should be fine. Is this okay? So we say x plus chunk width times x should be chunk length. So that's one mistake, first of all. That should be chunk width. Times z plus chunk width times y. Okay, so this might just be, we might have to do z here, chunk width, x here, chunk length. I don't think this is going to change much, but who knows? Maybe it will. So we'll try it out. Whoa, that changes a lot. Not in a good way too. So let's see. Like I wouldn't think this would make much of a difference because we're technically going in a square, right? This is all square except for the height. That's the only thing that changes. And do we have to take the height into account? Okay, maybe we should loop through this by going z. And this is going to be chunk length. And then we'll do y last. And that will be chunk height. Okay, and then this should be chunk height because y is in terms of height. This should be chunk width. That's fine. Okay. Let's see what happens now. We get an index out of bounds error. Okay, so what did we do here? We basically just screwed something up. I think this is right still, though. I just want to get one chunk on the screen by the end of the stream, and I think I'll be happy with that. So let's see what's going on. I think this is the problem. It's got to be this. The way we're expanding the array. Okay, let's go to the drawing screen because I think I need to do some real math here. Okay, so let's think about this. So if we have some 3D space, let's just use this. So we have some 3D space. And we basically want to map from X, Y, and Z. So this is like our height. This is our width. And then imagine we had an array going backwards, and that's our depth. Okay, and we want to map from this into just a one-dimensional array. What we could do is we could say, okay, so this is like a 0 there, and then there would be zeros going back, and then there would be like that, right? So we basically just have this, sort of this imaginary 3D thing. We want to map this guy to here, and we want to map this guy to here, and then we want to map him to here, and then eventually we would map him to here, and then we would eventually go down here, and then we would keep mapping. So how do we expand this? Well, this guy is just going to be his XYZ position, which is going to be the top left, which is basically going to be, if his X and this picture is the depth and Z is the length, it would be Z. Okay, so that's the width, Z plus. And then we need the depth, which would be X times the depth, right? Yep. And then if we want to go down, we basically need that height, which is the same thing. So plus whatever the Y value is, which I think is something similar to what we had before, but we're missing something here. I'm going to Google this again because people on Google are smarter than I am. So let's go back to the mainstream. Let's go to Google. Expand 3D array to 1D array. Okay, yeah, so he says X plus width times Y plus depth, or Y plus depth times Z. Let's copy that. So that's going from XYZ to a flat array, which should be good with me. So then if we just copy all of that there, X plus chunk width, Y plus depth times Z, chunk length. Okay. I think that should be good. Nope. It's an even shorter chunk now too. That's really weird. And I don't know why it turns green like that. Maybe it's because we're running out of room in a uint 32. I don't think that should be a problem, but maybe it is. Actually, no, vec3 is a float, so I don't think that should be a problem. Okay, and then for the UVs, this all should be correct, I think. So array expansion, which is just this, plus I times 4, which I think should be right. Actually, I think this is probably wrong, and that's why it turns green eventually. Yeah, because I don't think we should be using array expansion. We should probably be using const int UV offset, or UV index equals array expansion times 4. And then we could change this to UV index. Okay, so let's see if that fixes the texture issue. It looks like it almost fixed the texture issue. It fixed some of it, but we're still getting wrong. So I think we're probably still... Oh, that's because this is going 6 times, so times 24. Okay, there we go. So that fixed the texture issue. Cool. Cool. We're working our way there. We're still getting issues with our vertex offset, though, is what I'm thinking. So array expansion times 24. Is that correct? Let's think about this. Okay, so how many vertices do we have per cube? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4. Yeah, we got 24. Okay. So that should be fine. And then elements. How many elements do we have per cube? 6 times 6, 36. That should be fine too. Yep, that all looks fine. Huh. Maybe we should just leave it at where it's at right now and then pick this up in the next stream, because I am running out of steam here, guys. I think this is pretty good, though. We're getting closer to something that works. I might work on this offline and get this bug fixed so that we actually show like a real chunk. And then once I get that fixed, next stream, we're probably going to go into like texture mapping. So getting the appropriate textures for the appropriate blocks and everything. So that will be coming up with some sort of block structure. But yeah, I think this is where I'm going to leave it for this stream. Thanks everybody who is here to watch. And if you're here on YouTube, thank you as well. And I'll see you guys in the next stream, which will happen next week at around 9 a.m. CST. So I'll see you guys then. Thanks.